Hi children, good morning. How are you? Yes, I hope all are fine. Yes, very good. Then, in the previous class, what we saw in the class we went to, yes, the previous class topic is the early concept of Dauberinier and Triad's law and Newland Octavius law and Mendeleev law, and then in the classification of the elements in the blocks. Yes, so how many blocks are present in the periodic table? Yes, there are four blocks are present in the periodic table. So what is the name of that blocks? So that block is S block, B block and D block and F block elements. Yes. Then which types of elements present in the periodic table? Yes, three types of elements present in the periodic table. Yes, so one is metal, another one is non-metal and metalloid. So three types of metals present in the periodic table. Okay, yes, very good. And now today we are going to study about in the advantages of periodic table. Okay, advantages of the modern periodic table. So all of you see the modern periodic table. So first all of you memorize the first 30 elements. Okay. So first element is hydrogen, atomic number 1. Then second element helium, atomic number 2. Then atomic number 3 lithium, Li, beryllium, Be. Then atomic number 5 boron, B. Atomic number 6 carbon, C. Then nitrogen, N. Then oxygen, 8. Oxygen, the symbol is O. Then fluorine, atomic number 9, the symbol is F. Then 10 neon, the symbol is Ne. Then 11 and 12 is the metal, is sodium and magnesium. Then 13th to 18th is the metal and non-metal, is the name is aluminium Al, silicon Si, phosphorus P, sulfur S, chlorine Cl, then argon Ar. Then 19th to 30. Okay, so potassium K, calcium Ca, scandium Sc, titanium Ti, vanadium V, chromium Cr, manganese Mn, iron Fe, cobalt Co, Ni nickel, Cu copper, Zn zinc. Okay, so all of you memorize the first three atomic number elements. Okay, so then the advantages of modern periodic table. So first the elements is arranged in the increasing order of atomic number. So right is 1 2 3 4 5 6. So is the increasing order of atomic number. So the first point is the elements are arranged in the increasing order of atomic number. Then the Mendeleev it explained the position and the electronic configuration of the element is clearly. So the first element is hydrogen. So the first element electronic configuration is 1s. Then second element the electron is 2 electrons. So how many electrons? The electrons is present in the atomic number, same atomic number, because the atomic number 2 means the electron, the helium around the electron is 2. Boron atomic number 5 means the boron around the electrons is 5. Okay, so the lithium 3, the lithium around the electron is 3. So in the first two, hydrogen and helium is completely filled the first cell. Hydrogen 1s1, helium 1s2. Then lithium and beryllium is the second layer is formed. Second layer of cell is created. So the 1s2 is filled in helium. Then the lithium, the atomic number 3, so the electron is 3 electrons. So is 1s2 and 1s2 and 2s1 is the lithium electronic configuration. So the Mendeleev periodic table explain the position. Okay, explain the position and the electronic configuration of the element is clearly. Then in the each period is more logical. Then the period of atomic number increases, the energy of the cell in electronic configuration filled the electron up till the inert gases or noble gases group is reached. So see, in the last 18th group is noble gases group. So in the noble gases group is helium, neon, argon, krypton, xenon and radon. So these are the noble gases group. So in the first hydrogen to helium. So hydrogen is incomplete the shell, helium is completed. Okay, then lithium is the incomplete or the second shell. So in the neon is completed. So sodium is incompleted in the third shell. The third shell is completed to argon. Okay. So in the period of atomic number increases. Okay. So the third one 11, 12, then aluminium 13, 14, silicon. So the atomic number is increases. The energy of the cell electronic configuration filled the electron is substitute the inert gases electronic configuration. Then then the easy to remember the reproduce. Okay, so the atomic number increasing order, so the element is easily memorized and easily study in this periodic table. So in the each group is an independent. So in the is separate the metal is group 1 and group 2 is metal, and group 3 to 12 is a non-metal, and group 13 and 18 is a group 3 and 12 is transition metal, and 13 and 17 is a metal and metalloid group, and 18 is a inert gases group. So each group is an independent. So it has been discussed the subgroup. So the subgroup means S, P, D, F, the shell of this subgroup. So one position of an element is all isotopes is justified. So isotope means same atomic number but different atomic mass. Okay, same atomic number but different atomic mass. So one position of the element is all isotopes is justified. So the isotopes have the same atomic number. Then the position of eighth group. Okay, position of eighth group, the statement is correct in the Mendeleev periodic table. Then the transition metals are intermediate between the left to right portion of the periodic table. So in the transition metal is 3 to 12. Okay, the group number, the top to bottom. Okay, top to bottom 3 to 12 is the transition metal. So in this transition metal is intermediate between S block and B block. Okay, so the left and right portion of the periodic table. Then the next one is completely separate the metal and non-metal and metallides. So in the first hydrogen is a non-metal, but the hydrogen is arranged in the metal. So in the first two group is metals, and 3 to 12 is transition metals, and 13 only boron is non-metal, then aluminum, gallium, indium, titanium is a metal. Then 13 to 17 is a non-metal elements. Then so is completely separated. Okay, completely separate the metal from non-metal. So in the non-metals present in the upper right corner of the periodic table. Okay, non-metal is present as the upper right corner. Okay, in the periodic table. Then in the Mendeleev periodic table is interchanged the element or justified, because it is based on the increasing atomic number. Okay, increasing order of atomic number. So it can be placing the lanthanide and actinide at the bottom of the periodic table. So in the lanthanide series and actinide series is present in the bottom of the periodic table. So this is the advantages of modern periodic table. So in the next topic is position of hydrogen in the periodic table. Okay, position of hydrogen in the periodic table. So which one is the first element in the periodic table? Yes, hydrogen is the first element. So the hydrogen atomic number 1. Yes, very good. So the hydrogen atomic number 1, hydrogen is the first element. So hydrogen is the lightest and smallest in the first element in the periodic table. So hydrogen electronic configuration is 1 as 1. Okay, hydrogen electronic configuration is 1 as 1. So hydrogen is a unique position of periodic table. It is a alkali metals of halogen. So hydrogen metal 1. So in any reactions, so in this hydrogen is loss of one electron. Okay, loss of one electron, hydrogen get positive charge, and less of and gain of one electron. So hydrogen gain of one electron means one electron is gain accept the one electron. So the hydrogen get two electrons. Okay, hydrogen get two electrons. So two electrons means is the nearly to the inert gases. Okay, nearly to the inert gases group of helium. So the helium atomic number is 2. So in the hydrogen is present in the non-metal properties, is the halogen properties. Then hydrogen is a loss of one electron is formed hydronium ion H plus. Okay, hydrogen have only one electron, so that one electron is lost. Okay, so hydrogen loss of one electron, so hydrogen to form hydronium ion H plus. Okay, hydronium ion H plus. So it's like alkali metals. Then hydrogen is gain of one electron. So in the hydrogen to form hydride ion. So the hydrogen ion is H plus and hydride ion is H minus. So it likes halogens. So alkali metals are solid. Okay, alkali metals are solid, but hydrogen is a gas molecule. Okay, all alkali and alkali earth metals are solid, but hydrogen is gas molecules. Okay, so this is the hydrogen position. Then study about the shell number. Okay, study about the shell number. So all of you take your book, page number 144. Okay, so see the table number 12.6, the number of electrons in subshell. So in the subshell is 1s and 2 layer of second layer 2s and 2p, then third layer 3s 3p and 3d, then fourth layer is 4s 4p 4d and 4f. So these subshells is how many electrons present in the each subshell. So in the first shell, okay, first shell K, okay, first shell K, the subshell is only S. So in the 1s, so 1s subshell is present in the electron is only 2 electrons. Okay, 1s subshell, the presence of electron is 2 electrons. Then in the second layer, okay, in the second orbital layer, the shell is L. Okay, L. So in the subshell name is 2s and 2p. Okay, 2s and 2p. So 2s subshell is present in the electron is 2 electron. Then 2p is presence of electron is 6. So total number of electron is 8 electrons present in the second layer. Okay, 8 electrons is present in the second layer. For example, so all of you write in your classwork note, hydrogen, the simple the name of hydrogen and the simple height, then the electronic configuration is 1s1. Okay, then in the helium is the simple He, the electronic configuration is 1s2. Then the next one is the lithium. Lithium is the electronic configuration is 1s2 and 2s1. beryllium electronic configuration is 1s2 and 2s2. Then boron electronic configuration is 1s2 and 2s2 and 2p1. Okay, so the boron is a B block element. Yes, boron is a B block element. So in the last finishing the orbital is B. Okay, so boron, so all of you write boron is the electronic configuration is 1s2, 2s2 and 2p1. So carbon electronic configuration is 1s2, 2s2 and 2p2. The nitrogen is 1s2, 2s2 and 2p3. Then oxygen 1s2 and 2s2 and 2p4. Okay, so in this last p orbital electron, so in the last helium is 1s2 and 2s2 and 2p6. Okay, 2p6. So is the neon is completely filled the second layer. Neon is completely filled the second layer. So this is the arranging order of electronic configuration. So first 1s and 2s 2p and 3s and 3p 4s. Next one is 3d and 4p 5s. Then 4d is 5p 6s. Okay, this is the arrangements of the electronic configuration. Okay, arrangements of electronic configuration. So all of you see the table 12.6. So in the S or S subshell, okay, S subshell is the electron is 2 electrons. Then 2p and 2s and 2p subshell, the presence of electrons is 8. Then third orbital layer, the presence of electron is 18. So 3s is 2 electron, 3p the presence of 6 electron, then 3d the presence of 10 electrons. So total number of electron is 18 electrons. Then in the fourth layer, the fourth period elements is the elements are rotating around the nucleus to form the fourth layer, orbital layer. So in the 4s subshell is presence of 2 electron, 4p, 4s and 4p, 4d and 4f. So d orbital 10 electron, f orbital have 14 electron. Okay, so total number of electron is 32 electrons. So next one, the position of rare gases. So what is rare gases? So rare gases means noble gases or inert gases. So in the noble gases group elements is helium, neon, argon, krypton, xenon and radon. So these elements are present in group 18 elements. Okay, group 18 elements. So in this elements is monoatomic gases. Okay, monoatomic gases atom. So in these elements is do not react with the other elements. Okay, these elements is do not react with the other elements. So in these elements is completely filled the subshell. Okay, completely filled the subshell. Then in this inert gases is found in very small quantities. Okay, inert gases is found in very small quantities, so it is called the rare gases. Okay, rare gases means noble gases are inert gases. That noble gases present in the element is helium, Hg, neon, Ne, argon, Ar, krypton, Kr, xenon, Xe, radon, Ra. Okay, these are the noble gases elements. So these elements is present in group 18. Okay, this is the position of rare gases. Then metal, non-metal and metallites. Okay, so which groups are present in metals? Yes, very good. So group number 1, group number 2 is the metal, and group number 3 to 12 is transition metals. Okay, so these are the metals. So this metal is very hard and shiny and malleable and fusible and ductile characters of good electrical okay, good electrical and thermal conductivity. So in this metals is very hard and very shiny particle, and then good electrical conductivity. So good electrical conductivity, one of the example is sodium metal, okay, sodium chloride. So in this, sodium get positive charge and chlorine is negative charge. In the sodium chloride present in the table salt, so in this solution is the good electrical conductivity solution. Then the next one, the lithium metal, okay, lithium, the first group metal, okay, first group metal is the hydrogen. Hydrogen is not a metal, is a non-metal. So lithium, sodium, potassium, rubidium and cesium. Okay, this is a alkali metal. So lithium metal is used in batteries. Okay, lithium metal is used in batteries, and sodium metal is used in electrical good electrical conductors and is thermal conductivity. So this is a characteristics of metals. So all metals are in the physical state is solid state, okay, solid state. So in the solid state of metals at in room temperature, then many metals are present in large area in the periodic table. Okay, so periodic table is almost most of the element is metal, some few elements is non-metals. Okay, then the examples of metals, the alkali metal, okay, alkali metal. So alkali metal in your table, the first and two group. So in the first group is called alkali metal, lithium to francium. Then second group is called alkali earth metal, beryllium to radium. Then transition metal is group 3 to 12. Then D block metals is aluminium, gallium, indium, titanium, tin and lead and bismuth. So these elements are called metals. Then non-metals. So in this non-metals is the characteristic like is hardness and shiny and malleable and ductile characters. So in this non-metal is do not have the properties of metals. Okay, so metals is have different to the non-metals. So separated to identify to separate the metals and non-metals. So in all non-metals is arranged in B blocks only. So all of you check your periodic table column. So all non-metals is arranged only the B block only. So for example, in the non-metals is carbon, nitrogen, oxygen, phosphorus, sulfur and selenium and halogens groups. So in the halogens group means what? Yes, the halogens group means is fluorine, chlorine, iodine, bromine. So these are the halogens group. Then inert gases group. Inert gases group is already studied. So the inert gases group is helium, neon, argon, krypton, xenon and radon. So metals and metalloids. Then another one topic is metalloids. So in this metalloids means both the characters of metals and non-metals. Okay, both the characters of metals and non-metals. So the elements which have the properties of both metal and non-metals is called metalloids. Example, boron and arsenic. Boron B, arsenic Ar. Okay, then next topic is alloys. So the alloys means, so definition of alloys, so all of you underline. So alloys are the mixture of two or more metals. Okay, so in the last four lines, okay, last four lines. So alloys are the mixture of two or more metals and are formed by is the minimum molten metals is through 3. So these are called alloys. So one mistake. So the alloys are mixture of two or more metals and are formed by the mixing of molten stage. Okay, molten stage is through 3. So this is called alloy. So in this alloy, in during 3500 BC, the people used the alloy is named in bronze. The bronze is the mixture of two metals is copper and tin. Okay, copper Cu and tin Sn. Okay, so in these two metals are mixing in the molten stage of bronze alloy. Okay, bronze alloy. So then the bronze alloy used in the one example. So the bronze alloy is used in the Olympic medals. So in this medal is formed in the bronze alloy is copper and tin. Okay, so this is the alloy. So in this alloy is prepared in the two metals. So in the two metal means is copper and tin. So in the next example of alloy is brass alloy. So in the brass alloy is used in the metal is copper and zinc. It is used in the gold metal. So gold is simple is Au. So gold is not pure, not in the original pure form. So in the gold is added in the brass alloy. So that alloy is copper and zinc. So the gold is pured. So two alloys, one is bronze alloy and another one is brass alloy. So in the bronze alloy, the metal is copper and tin. Then in the brass alloy, the metal is copper and zinc. So two alloys are studied. Then the advantages of alloy. So in the alloys is do not get corroded. So the corroded means in the corrosion form. So the get corroded alloys is very less extent. Then the alloys is very hard and strong. So in the gold is mixed with the alloy of brass alloy is copper and zinc. Then in the alloys is good electrical conductivity of metal. So in the brass alloy and bronze alloy is presence of copper. Okay, brass alloy is copper and tin and brass alloy is copper and zinc. Bronze alloy is copper and tin. So these two alloys is the major element, major metal is copper. So in the copper is a good electrical conductivity, is the heat and electricity. So in the alloys is less conductance than the pure metal. So in the bronze alloy are not good conductors. So brass is copper and zinc, bronze is copper and zinc. So in the brass alloy is good electrical conductivity and bronze alloy is not good for conductors. Then in some alloys is low melting point than the pure metal. Then the last one, the metal alloy is a mercury is called amalgam. So amalgam is one of the alloy. So one metal is added to the another metal. So that one metal is mercury. So mercury metal is added to the another metal is called amalgam. So one of the dental filling amalgam is called alloy. Okay, and dental filling amalgam is called the alloy. So amalgam is used in the dental filling agent. So these are the advantages of alloys. So today we are study about the advantages of Mendeleev periodic table and the position of hydrogen and position of rare gases and types of elements is metal, non-metal and metallize, and another one of topic is alloys. So now your homework. So all of you write in your homework. So hydrogen. So what is hydrogen? Atomic number. Then write that hydrogen electronic configuration. Then the metal and non-metal differentiation. Okay, metal and non-metal differentiation. Then what is alloy and different and their advantages of alloy. Okay, so the first question, hydrogen. So what is hydrogen atomic number and their electronic configuration, and then the differentiation of metal and non-metal, and what is alloy and then advantages of alloys. Okay, thank you children.